All right, hello everybody. For this validation, we're going to take a look at a thick-walled cylindrical vessel with uniform internal radial pressure. It is a Rourke and Young example, and what we're going to do is take a look at the hoop stress and radial deflection. The dimensions are an outside radius of 10 inch, inside radius 7 inch. The height will be 8 inch. Internal pressure is 10,000 psi. Poisson's ratio 0.3 and a Young's modulus of 30e6 psi. We are going to use quarter symmetry here. We know what our max values should be, and then we'll plug in those values once we have the model complete and take a look at how we compare. So I have my Autodesk Inventor Professional 2022 open here. I'm just going to start a new sketch. And we'll just go ahead and select the plane. I'm going to choose the XZ plane. Doesn't really matter too much except for when you are interrogating the stress tensor results, but we're going to do a circle. I'll start at the origin, just drag it out, repeat that process, and then we're going to go ahead and dimension. Again, the inside diameter, well, they define for us the radius, but the inside diameter then would be 14 inch. And then the outside of this would be 20 inch. And I'm just going to draw two lines from the origin, one in the vertical, and then another one from the origin out in the horizontal. So it's such a simple geometry. I'm just starting from scratch here just to show you how to create the geometry and just trimming out the portions that we don't need. From that point, we can go ahead and finish our sketch and extrude our geometry. And we're extruding it 8 inches up. And now we have the geometry created. I'm just going to go ahead and save it. Make sure we're in the correct directory. And we'll assign it some name. At that point, we can go to the Environments tab and get into Autodesk Inventor Nastran. So pretty simple on the setup here. The idealization, because we made a 3D model, it knows that it wants to have solid elements. So you can see that the element type is already set. We do need to define the material. And I'm just going to right click on the generic material that it assigned there and get into the material screen now. We could go with a select material and go through the library and grab a material that has the properties we want, but given that the modulus and Poissons were defined for us, we could just type in the screen here. And the modulus was 30e6. Poisson's ratio is a 0.3, so we'll just type in the material properties in this case. And then let's go to constraints. This is one of the symmetry planes. This is a symmetry plane, and we'll constrain the bottom. So on this face here, we'll select that face. The Z is perpendicular, so I'm going to choose a Z symmetry. And we'll say OK. Again, going to constraints, this face over here is X. So that's an X symmetry. And again, we'll say OK. Whoops, I didn't actually select that face. And I can say OK. And then at the base of this model, we're just going to constrain the vertical direction, which is the y-axis. So I'm going to choose free, and then we'll assign a ty constraint. And then for the loading, the load was 10,000 psi, so I'm going to go to loads, select the inner surface, change the type of load that we are assigning to a pressure, and it is 10,000 psi. All right, and then we can go ahead and say generate mesh. I'm just going to accept the default mesh, probably a little finer than we need it to be. At that point, we're ready to run the model. You can see we have 15,000 nodes in this one, so it shouldn't take too long to run. And then we can check our results. All right, so the first thing we're going to take a look at is the deflection. So once I get into the results from the pull down menus up towards the top here, I can tell it that I want to take a look at displacement. And we could either look at, since we're looking for the radial growth on this face, we could look at the Z or on this face over here, we could look at the X. So let's take a look at the X. And you can see by the legend it ranges from 0 to a negative 0.008, or more precisely, if we look down at the very bottom of the screen, we can see it's a 0.00766. So let's go ahead and plug that value in, 0.007, and then I'm going to use the same number of decimal places, so it's 667. And if I hit enter, the percent difference on the displacement is just about 2%, so not bad at all. And then let's take a look at one of the radial stresses. So for that, I can go to the pull down menu, change to a stress, and I'm going to look at one of the stress tensors. Similarly, over here, we can take a look at the Z tensor, or if we want to look at this face, we can take a look at the X tensor. So let's go with I think it's already on the X, yep. And that gives me a value of 29,348. So if we plug that value in, 29,348, we see a percent difference of 0.45%. So really good agreement this week with what our hand calculated values should be. And so hopefully that's a good example. And thanks for watching. Take care.